Hi, welcome back to the channel. In today's lesson, we'll see specific heat capacity. I will explain the concept and also use a practical example to help us understand the concept of specific heat capacity. That said, let's get back to class. Specific heat capacity. The heat capacity of an object or of a substance is the amount of heat required to raise the temperature of that particular substance by 1 Kelvin. That is, if I have probably a jar of water this way and I have it on a burner being heated up. If I have this jar of water being heated up and I have some quantity of water here, the heat capacity of this liquid here or this water here is actually the amount of heat I will pass in through this burner to this water to raise its temperature via 1 Kelvin. Now, you agree with me that the amount of heat I'll pass in to raise the temperature of water, or let's say a better way to understand it. If I have water and I have to raise the temperature of water probably to boiling point, you agree with me that the quantity of heat I will have to pass in will be far higher than when I have to raise the temperature or I have to boil oil. Now, if I have oil in the same quantity here, I'll be passing less heat to raise the temperature of oil. That is to say, the heat capacity of oil in air is far less than the heat capacity of water. Now, another case is if I have a substance probably like aluminium or like copper or a metallic substance generally. You agree with me that the heat needed to raise the temperature of this metallic substance through 1 Kelvin is actually far less than that of water. Now, the bottom line here is this. Or for heat capacity, we're actually thinking of the whole substance to raise the temperature of this substance. But when I begin to talk about specific heat capacity, we begin to talk of to raise the temperature of 1 kg of that substance. And that is why in most examples, we refer to specific heat capacity. Now, let's see this. The quantity of heat required to raise the temperature of this jar, Q, is proportional to the mass. That is, if I have water in this volume, and I have less water also, probably half of this in this volume, the amount of heat I will need to raise the temperature of this through 1 Kelvin, it will be far higher than what I will need to raise this amount of water. That is, to raise less amount of water, I will need less heat. To raise a higher quantity of water, I will need more heat. So we say that the quantity of heat required is proportional to the mass. Also, the quantity of heat required is proportional to the change in temperature. That is, I'll be raising the temperature from θ2 or from θ1 to θ2. So I'll be saying that the quantity of heat required is proportional to the change in θ1, θ2 minus θ1. That is, this is proportional to change in temperature. Now, so we can now conclude that the quantity of heat required to raise the amount of 1 kg of a particular substance, to raise the amount of 1 kg of through 1 Kelvin is directly proportional to the mass and change in temperature. So that the quantity of heat is equals to mc delta Q. We have introduced C now to remove our sign of proportionality. So that the quantity of heat Q, this is Q is equals to mc delta theta. Now let's see a practical example that can help us understand it better. Now our example says that an electric heater of 60 watts is used to heat a metal block of mass 20 kg, I want us to say the mass M of this block is given as 20 kg and it is heated for 5 minutes. The time taken to heat it is how many minutes? 5 minutes. Let's convert this to seconds first. That's 5 times 60 because our SI unit for time is in seconds. That's equals to 300 seconds. Now, and calculate the specific heat capacity of metallic block if the rise of temperature is 20 degrees Celsius. That is, my change in theta in this case is 20 degrees Celsius. And the power output of the heater, the electric heater, is given as 60 watts. Now, I want us to remember something first, that power is always equals to joules, which is energy, is always equals to the energy over time. So that my energy, the energy Q dissipated by that heater is given as 60, which is the power, times the time taken, which is 300 watts. That's equals to 18,000 joules. That means I have 18,000 joules to transform the state of this metallic block in 5 minutes via a temperature of 20 degrees. Now remember that my Q is equals to MC delta theta. Already I have delta theta and I have M. I'm looking for C. So that my Q over M delta theta will be the same thing as what? As C. So that my Q is 18,000 joules. My C now will be the same thing as 18,000 all over M is 20 times change in temperature also is what? Is 20. 0 here is 1. 0 here is 1. I have 2 here. In the remaining 180, that will be 90. And I have 2 here. In 90, that will be 40, 45. So that my C will be given as 45 joules per kg. 45 joules per kg. Is worth noting that the SI unit for specific heat capacity is the same thing as joules per kg per Kelvin, while the SI unit for heat capacity, not specific, when it becomes specific, like I made mention initially, we talk about it in terms of per kg, but joules per Kelvin will be the joules per Kelvin will be the SI unit, for heat capacity. Thank you for staying with us, and please do not hesitate to hit the subscribe button, and see you in our next class. Thank you.